Hey, so this is the lesson proper. We're going to talk about angles and lines of symmetry. The main topic for today is angles. Okay, we're going to build your skills from scratch on working out angles. By the end of today, you'll have fantastic skills. You'll be able to work out all angles in funny shapes and it won't be an issue. Lines of symmetry is kind of a little bolt-on. As the objectives today, we're going to recall and use the properties of angles at a point. Okay, and we're going to talk about angles on a straight line, angles on perpendicular lines, and opposite angles at a vertex. Don't worry about vertex, we'll talk about angles. What's an angle? We have a big board today. What's an angle? Definition of an angle.
Degree of 360.
A circle's got 360. What's an angle?
Is it a corner?
Yeah, it's a corner. It's where two sides meet, okay? So it's where two lines meet, it creates an angle. Don't have to understand the definition, you just need to know what an angle is. We've got this word, vertex. Anybody know what a vertex is? And it isn't when you empty the bath and that swirly thing.
Is it a vertical line? Something to do with a vertical line?
Ooh, sort of. Think angles today. What do you reckon a vertex is? Have you heard of the word?
On a bend.
Brilliant, yeah, it's a corner. It's a posh word in maths for a corner. You will get in exam papers, circle the vertex or circle the largest vertex. If you don't know what a vertex is, you cannot answer that question. So it's one of these words they're going to stick in the exam that you need to know the definition of in order to answer a question. We've come across letters before when we did Unit 2. Anyone remember what we used letters for?
When you don't know
Yeah.
the figure.
You don't know the number. So we used it in algebra, didn't we, when we didn't know something. In Unit 3, it's slightly different. In Unit 3, we're going to use letters to define things. Okay? We use letters to define a point. They might say, go to point A. They might say, the line BC. Or even worse, the angle at E. Now there's two ways of discussing this angle. Okay? And this is really important. They will give you information on angles in one of two ways. They might say the angle at E. So it's saying I'm interested in that angle. Or they might say the angle at DEF. Why have I written it that way?
Because it goes like that.
Because when you look at DEF, the angle is in the middle. So the angle's always in the middle when they're defining an angle. So if I drew a different shape, let's say, and I've got angles F, G, H, I, and J, okay? If I said to you, what is the angle at GHI, which angle am I interested in?
Okay.
The one there at H. Okay? And that's really, really important in Unit 3. That when they give you an angle, they can give it you in one of two ways. The first way, they could just say, what's the angle at H? The other way is, what is the angle at GHI? Okay? And they're telling you they want the one in the middle. Does that make sense? And that's really fundamental to angles in these papers. They talk in terms of letters. Okay? And you'll see that in some of the examples. Right. Let's see what we already know about angles. So here I have my wonderful 360 degree protractor. Now, I should be able to touch that green dot, but it's not been working all week, so I'll use it this way. So I've now created two lines that have joined, and they create an angle. And I'm going around here. What sort of angle do I call it as I go around there?
That angle.
Sorry?
That angle that you just...
Yeah.
Acute.
It's an acute angle. That's what we call it, acute. And where does an acute angle stop?
90.
At 90. So an acute angle is less than 90 degrees. Yeah? So I carry on round and I hit 90 degrees exactly. Not 89.9, not 90.001, 90 degrees exactly. What sort of angle do we call that?
Right angle.
It's a right angle. Okay? And that's exactly 90 degrees. In maths, we can also refer to that as a quarter turn. Okay? So sometimes you might see it written 90 degrees is the same as a quarter turn. And that's what this thing about turns is. A full turn is 360 degrees. So a quarter turn also refers to 90 degrees. And in some papers, they've used the expression such and such moves a quarter turn clockwise. Okay? So you have to know what a turn is as well. So right angle is also a quarter turn. We've got to remember that word. I carry on going. I go to 91 degrees. What does the angle become now?
Obtuse.
Good. So anything greater than 90 is obtuse, but where does it finish?
180.
Good. So obtuse is between, it's greater than 90, okay, acute is less than 90, and less than 180, and that's obtuse. So I go round on my little 360 protractor, and I hit 180 degrees. I stop exactly on 180. What do we call that?
Is it reflex?
Half turn.
A half turn, brilliant. It's a half turn. Sorry. A half turn. What else do we call it? It's an angle, a particular angle. It's dead obvious when you look at it. It's a straight angle. Have you heard of that one? It's a straight angle, which is exactly 180 degrees, or as Lisa said, spot on, it's a half turn. Yeah? So it's called a straight angle. I go to 181 degrees and carry on round.
Reflex.
Brilliant.
Wait,
So anything greater than 180 is a reflex angle. And that is greater than 180. Okay?
So
And
an
it's
angle that is just at 80, 180.
it's called a straight line.
So
That's all.
not even like 180.1. It has to be.
Exactly. Like the right angle, it has to be 90.
Is it the same with 45 degrees? Is that just an acute?
That's just an acute. That's not got a special word.
Alright.
Okay.
It's been taught at school different.
Okay. So let's go back to 90 degrees and the right angle, because that was quite an important one. This isn't exactly right. Why is this protractor not right?
Square.
Good. It's really important to know, okay, that when you have a right angle, it has a square there, not an arc. And that tells you, you're going to get diagrams today, that your big hint is, if you end up with a square like that, it's a right angle. So that angle is 90 degrees. It's as good as them writing the word 90 in the angle when they do that, okay? So a right angle has also got that thing there, that symbology.
What's a reflex angle again?
It says there.
Something more than 180.
Yeah, greater than 180. Okay. So they're the words that we use for the angles, and you're going to need to know those words. Okay, don't worry about that, it's not working. So let's just do a quick recap on these words on the images that I've got here. Let's try and move that around a bit. Okay, so this angle here is acute because it's little, it's cute. This one over here, obtuse. This one here, right angle because it's got the square, so that's right angle. This one down here,
Reflex.
and this one,
Straight line.
good. Absolutely fantastic. What we're going to do now, and part of the reason you're sat as you are, is you're going to play a game. 2 against 2, 1 against 2. Okay? And this is, right, what we need to do now is we need to move on and not just recognise angles and give them names, we need to be able to estimate angles and also measure angles. Okay? So the next bit of the lesson, you're going to get a lot of hands-on stuff. So when you've got an angle by 2 lines joining, you need a process to estimate them. So if I want to give this an estimate, what reference can I use as a good estimate? What can I do to that to think, oh, it'll put me in the right ballpark? Think about angles that we know. If I do that, do I know what that is as an angle?
Right.
Yeah, I know I've got a right angle there, so I know that's 90. So I know it's less than 90, and it's probably bigger than the halfway point, which is 45. So
Angle.
sorry? Yeah, it's an acute angle,
So it's-
but we're trying to estimate what size.
It's in between 45 and 90.
Yeah, but if you were going to give it a value, what value would you
60.
give it?
60.
60. Let's
I
call
like
it 60.
60.
See what we reckon it's 60. So that's our. It's meant to be a 0. So we're estimating that it's 60. Now we need to measure the angle. This is where your protractors come in useful, if you've got one. Okay? We move the protractor and you put the crosshairs where the lines meet, in other words, at the angle. You then move the protractor round so that the 0 line goes along the line that you're measuring. And then you look from here, if this is 0, count round. 10, 20, 30, 40, 50 degrees. So our estimate of 60 is in the ballpark. It's not bad at all. Okay? Right. What if I said to you that angle was the reflex angle that I was interested in? How would you measure a reflex angle? So I'm not interested in the acute angle. What if I said to you I was interested in the reflex angle? What could I do there to measure it?
Could you not just like, could you know that's like 360?
Yeah.
So not just like,
You're there. Just push it
I want
out.
to say divide it.
Not divide it. What did
Not
we measure
divide it.
earlier?
I don't know.
The easiest angle to measure is an acute angle. So measure your acute angle, which we've already done, which is 50. I know a full circle is 360.
So would you take the 50?
Take away the 50 away. It tells me that my reflex angle is 310 degrees. So if you have to measure a reflex angle, don't start faffing around with a protractor and measuring 180 and putting a line. Just measure the acute angle and take it away from 360. Okay? So I'm going to give you some hands-on worksheets now. So you're going to need a protractor. I'll get you one if you haven't got one. And I want you to do 3 things on these worksheets. The first thing I want you to do is name the angle, whether it's acute, obtuse, reflex or whatever. The second thing I want you to do is take a guess at what the angle is. Okay? So look at the angle and say, ooh, it's roughly 50 degrees. And then I want you to get your protractor and measure it accurately so that you know if you're close with your estimate. That's all I'm saying. Okay. Let's move on to angles in everyday objects then. Angles are critical in everyday objects. You do come across them every day without realising it a lot of the time. So we need to develop our understanding of angles now and start thinking about angles within different scenarios, okay? And one of the scenarios could be, I've got a straight line here, and another line comes in and joins it, and it creates 2 angles, P and Q. Can you give me a rule for P and Q?
No, straight line adds up to 180.
Good. So P and Q have to add up to 180. That's our first rule. Okay? So on a straight line, angles will always add up to 180. Whether I put 1 line through there, what about 2 lines? So I've got a straight line and I've got 2 lines joining it. What can I say about P, Q and R?
Please, 90.
No, it can't be because it's got a little arch. If it was 90, it would have a square, wouldn't it?
Would it still add up to 180?
Brilliant. P plus Q plus R have to add up to 180 because 180 is a straight line, isn't it? So whenever you've got a straight line, whether you've got 1 line coming in, 2, 3, 4, all of the angles together have to add up to 180 degrees. Okay. Let's look at angles at a point. We've already done angles at a point because we've done pie charts. Yeah, so all of these angles around a point coming in from different directions have to add up to 360 degrees because they're a circle, aren't they? Yeah. So that's all this one's saying. That when you have angles around a point, they add up to 360 degrees. Essentially, it's a pie chart. What about angles where 2 straight lines cross? I know you won't remember him.
Still 360.
Adamant. 2 straight lines crossing. Yes, all of the angles add up to 360 because it creates a point. But what can I say about angle A and angle B?
Them 2 will be the same. They'll be
Correspondent.
Not corresponding.
Matching.
I know what, if you say the word, I'll know exactly what it was.
They're what we call opposite angles.
Opposite. Why did
A and B, because it's 2 straight lines crossing, A and B are opposite, so they're the same. What about C and D?
They're the same as well.
They're the same as well. So we've got another rule here, so we're introducing all these rules, where when you get 2 lines that cross, the opposite angles are always the same. So y is the same as y, x is the same as x. Good rules to remember this. Okay. Angles on a line. We all know that that's a straight line joining another line. And what sort of angle is it?
Right angle.
What's a posh word for a right angle? If I said to you, that line is something to another line. Quarter turn, good. But it's got another word that we use to say when something is at right angles to something. Begins with P.
Parallel.
Not parallel, that's...
Perpendicular.
Ah. Perpendicular. Okay? Perpendicular.
What it means.
You, in an exam paper, might get a question along the lines, draw a line between A and B. So you've got your 2 points and you draw your line. They will then say, in your construction type questions, draw another line to C that is perpendicular.
What does perpendicular?
Does it mean going in the opposite way?
What does perpendicular mean?
Yeah.
It means at right angles to. That's what we've just been talking about.
Sorry, I was just.
So perpendicular, if they said draw a perpendicular line to C, you draw C up there and you would draw something at right angles.
Wait,
So this
write
word
down.
perpendicular means at right angles to. So perpendicular is a posh maths way of saying draw it at right angles. Or a quarter
Spell it,
turn.
will we?
You might. You never know.
So it means to draw a right angle.
Draw a right angle. It's at right angles to something. Something is perpendicular to something, it's at right angles to it. I parked my car perpendicular to the lawn.
So like.
Okay? So let's have a go at a few. Have a go yourselves at 1, 2, 3 and 4 to work out the missing angle. So angle A in question 1,
Can you use
angle
a
D and E.
calculator in this?
Yes, absolutely.
Yeah.
I want you to use your calculator. Get your calculators out. Let's have a look at them then. So 1A, don't tell me the answer. How did we get it? What rule do we use?
The three.
Good, the 360 rule. So we know that the angles around a point are 360. So how do I work out what A is? What do I do?
Add 80 and 70.
Add 80 and 70 and I get...
That.
And then what do I do next to work out what A is?
Take that away. From 360, which is 200.
Take it away from 60.
110.
So A should be 210. Everybody get that? Sorted? Brilliant.
Is it alright to do like 360, take away 80, take away 50?
Perfect. Yeah. Lots of different ways of doing the same thing in maths. Okay? So question 2 then, what do we reckon? Who'd like to start me off? What's the easiest one to do, Amber?
Is it that 160 times 2? Because D is the same.
D's the same, that's the first bit. So D is 116, so you've solved the first one. And then times 2 tells us the total of those two, which is
232.
brilliant. So if that's 232,
You're going to take that away from 360. And you find
because
out
we've got
the
360 degree rule, so we take it away from 360 and it leaves us with
64.
good 64, 128.
128 divided
And
by
then
2.
divide that by 2, sorry.
It's 64.
And that gives you 64. So D's 64 and that's 64. Good
Yeah,
spot.
because I
Yeah.
did it a different way because I worked this out that obviously 160 so angles on a straight line.
Oh,
equals
brilliant.
180.
There you go. Just to show that when you're talking about these angles, there's 100 different ways of doing the same thing. So what Sam did is she said this is a straight line. So she said that's 116 and the straight line rule says they add up to 180. So she took 116 from
Left you 64.
180 and it gave you the 64 again.
Because the
So it
colour
shows
is
you
there.
these rules, you can mix and match, which is what we're going to do in a minute. Yeah? Absolutely perfect. Oh, I do like that. Oh, it made my day. Oh, sorry, I've got the other ones to answer. So this one here, B. What did we get for B? Adam, when you finished on your phone.
Sorry, I was just checking what's out.
Yeah, okay.
I actually was.
So-
I swear I was.
Question 3 then?
Oh, you want me to answer?
Yeah.
Alright, so it'll be 90, 75 plus 95, which is...
So 90 plus 75 plus 95.
Oh, you're making me do maths now, eh?
It's called a calculator.
185, so then add the 70, so 15, that'll be 260.
Brilliant. And that was off the top of your head.
Yeah, so it'll be 3, so it'll be 100.
So it's 100 degrees. Tell me you can't do maths when you can do things like that under pressure in a classroom off the top of your head. Okay. Question 4. Who'd like to have a go at 4? Anthony, you want to have a go at 4? What's the way of solving this one?
80 plus 135.
Good. 80 plus 135. 215.
Take 215 from 360.
Take it away from 360. 360 minus 215.
I'll give you 1.5.
1, 4, 5. Fantastic. Again, 360 degrees round the point. Absolutely brilliant. And that's objective 1 done. The recall use of properties of angles at a point and angles on a straight line. Okay, we're just going to have a look at some more rules now before we take a break. We'll cover the rules, we'll take a break and then do the worksheet. How does that sound?
Yeah.
Yeah, okay, game on. We're going to introduce parallel lines. What's a parallel line? What's the
Lines that
definition?
never meet.
Identical and
This is one of those words I can never spell right. I've been practicing all week.
Oh, I spelled it wrong as well.
Okay.
That's right there.
What is the definition of a parallel line?
Lines that never touch.
Brilliant. Lines that never touch. The posh maths way of saying it is lines that have the same perpendicular distance between 2 points. It's like, what? Lines that never touch. That'll do. You won't be asked to define it. Just remember they never touch. In maths, we draw these little arrows on them to represent parallel lines. If there were more parallel lines in the same direction, they would have 1 arrow. If I drew parallel lines that go in a different direction, they would have 2 arrows to show that they are associated, okay? But for now, all you need to remember that a parallel line has an arrow on it to show that they are parallel. So those little arrows annotate parallel, because we're going to come on to another notation in a minute that denotes length. So when you've got parallel lines and you draw another line through the parallel lines, it throws up a load of rules that we're going to have to go through. Okay? This line that goes through them has got a special word. Anybody know what this word is?
Doesn't.
Except when you're playing Connect 4.
Yeah. When
Isn't that right,
Some
James?
people cheat.
Well, we won't bring that up again every lesson.
Can I just say again, I was not involved in that. Just making that.
Angles and parallel lines, you're a team. Stick together, go down together.
Yes.
A transversal is a line that cuts through parallel lines.
Is it on the board all the time, that?
Yeah.
Oh,
it's-
God.
Oh, you hide the word
Yeah.
transversal.
Oh my word.
Okay. Oh no, I revealed it.
Alright, I was gonna say.
But normally you can see it, can't you? You stare hard enough, you can work out what's hidden. Okay? So it's called a transversal. It's the line that cuts through parallel lines. And it throws up a load of rules. The first rule is called the alternate angle.
Used to hate these, eh? Used to hate
Okay.
it. They were horrible.
What it's saying is that line that cuts through them, this angle here is exactly the same as that angle there. Because we've got quite a few 16 to 18s in here, at school it's known as something else. You used to call it the...
Opposite angle, no?
No, opposite angle is... We've done opposite, haven't we?
When we go like that.
Opposite was like an X, wasn't it?
Oh yeah.
It was that is the same as that. Remember what we call this one? What if I...
Oh, like F and Z and C.
Does that not look like a Z?
No, because you can
Yeah.
get somewhere they go like
Right.
that, can't you?
So this is the
I
Z
am right.
angle.
I
At
am
school
right.
they teach it as the Z angle.
Never.
Never heard of that.
Never heard of
I
that.
didn't teach it last year, right?
No,
But
even when I went to school.
oh right,
never heard of it.
okay.
Yeah, I
Some
don't
schools
think
call
so.
it the Z angle, and what it means is
Yeah.
this angle here is the same as that angle there.
Wait, which one?
The A's.
School 5 years.
Okay.
You got his.
I actually do, so.
Okay. So it's an alternate angle. So when you draw that line, this angle here is the same as that angle there, sometimes known as the Z angle. So at schools they teach it as the Z angle, so A is the same as B, or you can do the Z backwards, where D is the same as C. Does that make sense? Yeah? Yeah. Okay, corresponding angles. Here, when we look at our transversal, they correspond, they're on the same side as the transversal. So angle B is the same as angle B, angle C is the same as angle C.
What
Okay.
letter's that?
Sorry? What do you think letter is?
C. Is that C, that one?
F.
Nope, it's.
E.
F. It's called the F angle. It's saying that this angle here is the same as that angle there. They're on the same side as the transversal. Okay?
Which one was
So you'll tell me when you
transversal?
work them angles out.
It's
that's
the
it.
line that goes through the parallel lines.
Is that
It's this one here going from top to bottom.
oh.
The parallel lines are the ones with
Sorry.
the arrows on them.
Is it? So, I am totally lost how these work out. I don't get it at all.
Why?
I don't know, just what you're supposed to do, just work A and B out on their answers, that's it, done.
No. We'll give you some examples to work out. I'm just pointing out now that angle A is the same as angle B. They haven't got a value
So you
yet.
only have to work out one of them, really, don't you?
Yeah, generally. Or spot the missing one when we start compiling things. You'll see how it works in a minute when I give you the worksheets. Okay? What you're going to have to do is work out a missing angle based on some information, and you can use the alternate angle rule, the corresponding angle rule, or the next rule that we're going to cover. So they call this the F angle because it's the same side as the transversal. Okay? The next angle, in fact, let's go back because there was an example on this one. So angle is 115 there. Angle G there would be 115 because they correspond. They're on the same side as the transversal. Now we've got what we call an interior angle. Okay? And the interior angles, this angle here and this angle here add up to 180 degrees. Does that make sense?
Yeah.
Because where else is angle D?
Still the other side.
On the other side of there. So we know that D and E add up to 180 there. If this is the alternate angle, because it's on the other side, we know that that plus that equals 180. So we have three rules there. We have the alternate angle, the corresponding angle, and we know that the interior angles,
That's C.
and this is your letter C, add up to 180. So those two add up to 180. Okay? So here we've got our interior angles, A and B add up to 180, C and D add up to 180. And if we were applying it to a problem, I've got 40 degrees there, I can work out what this angle here is.
Which would be 140.
Good, it's 140, because our interior angle rule, there are interior angles. I know 40, so that must be 140. If that's 140, this is
40.
That's
40, because it's on a straight line. So it's 40.
So that
And it's
A-
also
That A would be 140.
our Z angle. If that's 40, this angle is 140, because it's on our straight line, or it's our Z angle with that. Okay? So there's lots and lots of ways of working out the same thing. That's what you're going to do in your worksheet.
Talk about headache.
You haven't? Yeah, it gets worse. Wait till later, you'll really have a headache. Okay.
Sign me up.
So let's have a look at this then. Work out the values of the angles. So let's talk about these, take a break, come back and do the worksheet, okay? So I've got 65 degrees here. What angle is P and why?
65.
Good, Anthony, yeah? 65 degrees, and what's the rule that tells me that that's
It's
65? It's the F angle, which is the corresponding. So that's corresponds, okay? Okay, I've got 38 degrees here, and I've got Q. What is Q?
38.
Good. And what angle? What rule told me that Q was
Is
38?
that the Z and Z?
Which is, I'm reading it up there yet. The
And
alternate. It's on the alternate side of the transversal. So that's the alternate angle. We can do this one in lots of ways. Who'd like to start me off with either
one?
S or R? Go on in, Sam.
R would be
Yeah.
103 because it's on a straight line. So you do 180 minus the 77.
No, that's our transversal here,
So this is where I'm getting confused.
right?
R is 77.
R is 77 because it corresponds to this 77.
So you don't go along with the 180 straight line.
This angle here is the one that you're talking about, which is 103. Yeah? But this is the transversal, so if that's 77, that must be 77 because it corresponds.
So F has to be
so that's
So 77 for R, we got through corresponding angles.
So that's S.
S is what angle? You'll get it with the practice.
S is 77.
77.
77 because of which rule? You can use
C.
C angle.
And it's when
No.
two lines cross.
Because when two lines cross,
Well, because
that
that's
angle
one.
is the same as that angle.
I was
Okay.
going to say that, but later. But
Right. So let's write these down, and we'll just do one last go through them so that you can. Okay. If you've finished before your teammates, give them a hand. So don't go on to the second page, but help your teammates out if they're struggling. Okay, we're going to move on now to shapes. We're going to look at angles in shapes. So that's the end of objective 2, which is angles with parallel lines. Okay? So what we're going to do now is going to look at angles in shapes. And we're going to try and discover something today that you can amaze your friends with. I've got a shape here. Everyone recognise the shape?
Square.
What's the angles inside a square?
90.
Right.
Right angles?
360.
So they all add up to 360. So what we call the interior angle for a square add up to 360 degrees, don't they? What if I haven't got a square? What if I've got one of these things, which is a
Same thing.
Rectangle.
rectangle? What do they add up to?
Same thing.
360. Because again, I've still got 4 right angles. My interior angles on a rectangle add up to 360. I'm not going to get you to do this, but look at this shape on the board. What do the interior angles of that? What is that shape for a start?
Hexagon, isn't it? A polygon.
It's a polygon.
Trapezium.
It's an irregular trapezium. We'll learn shapes next week, so I thought I'd just touch on them this week. It's a 4-sided shape for now. What do the interior angles on that 4-sided shape add up to? 360 degrees. So any 4-sided shape, doesn't matter what I draw, a kite, a rhombus, a parallelogram, all these things you've heard of, they add up to 360 degrees. This shape, 360, and it's a regular trapezium. This shape,
Rectangle.
parallelogram, don't worry, we'll learn them next week. And the interior angles of that
360.
add up to 360. But they throw up some strange properties. This angle here, what's that the same as? This one down here, what's this angle equal to? That one there. Parallelogram, this angle here, which one's that equal to? Up there. This angle here, which one's that equal to? That one down there. So parallelograms have properties where when you start bending things or making these shapes, some of the angles start matching each other. We're going to cover that next week as well. Okay? Let's look at a triangle. I'm not going to get you to do it. I'm going to draw a triangle. Any old triangle. Okay? What do the angles inside a triangle add up
Always
to?
out today.
180.
180. Brilliant. So if I look at the various triangle types, a scalene triangle. What's a scalene triangle?
We're all bit.
Dodgy.
Where the one side is different to the 2 sides.
Bit more than that. What's a scaling?
Got an obtuse. One's an obtuse.
Not quite.
The all acute angles.
No, that's obtuse. What's different about it? What are the 2 things we're talking about with these
All
shapes?
different sides.
Good.
Are
All the sides are different, in other words, different lengths. But what else has to be different?
The angles.
Brilliant. So the way you define a scalene triangle isn't just all the lengths are different sizes. Okay? All of the angles are different. All of those 3 angles have to be different for it to be scalene. Because when we look at this triangle, now these notches mean something in maths. What do those notches mean?
Same side.
They're the same length. Yeah?
Parallel.
So if those sides are the same length, what else is the same length? The angles there are the same. So an isosceles triangle is defined by the fact that 2 of the sides are the same length, or the fact that 2 angles are the same. Because if 2 angles are the same, 2 of the sides have to be the same. So everyone gets it into their mind, it's the 2 sides.
Usually 75.
Think about 2 angles and you'll get questions where they'll give you a shape to draw or measure, and 2 of the angles will be the same, and they'll say, what sort of triangle is it? And the answer is, it's isosceles, because if 2 angles are the same, it has to be isosceles, and 2 of the sides will also be the same. And that's really important. We'll cover that a couple of times when we do construction and other things. Okay? What's the other type of triangle? We've done scaling, we've done
Right angle.
and what's the other one?
Equilateral.
Good. So what's equilateral triangle telling
They're
me?
all the same. So
What's all the same?
all the angles and the lengths of the sides.
Brilliant. So the length of the sides are all the same,
Triangle.
and all the angles are the same. So if all of the angles are the same on an equal triangle, what does that angle have to be?
180 degrees.
60.
All adds up to 180 degrees.
60 each. So an equilateral triangle, when you do construction, the angles have 60 degrees, and that's really important. So if you get an angle of 60 degrees on 2 of the angles, the third one has to be 60, and alarm bells start ringing. And I'll talk about these alarm bells when we get into construction, because this is their favourite type of triangle for you to draw, an equilateral one. And when we come to construction, you can draw this by drawing the same angles. Forget about the length of the sides because they will automatically become the same. Okay, so an equilateral triangle, and you're quite right, that's a right angle triangle, which is a very special one, which we'll cover when we do Pythagoras in a couple of weeks. But again, the interior angles all add up to...
Sorry, what was that word? Pythagoras.
Yeah, it's not a, it's a name, it's a bloke, it's a relative of mine. Okay, so
Is it?
a right angle, well he's Greek, my mum's Greek, so I claim it. Okay, so I've got a right angle triangle here. So what do the interior angles on a right angle triangle add up to?
180.
180, okay?
Never know.
So let's see if we can come up with a rule.
Wait, I need to write stuff.
If a triangle angles add up to 180, and a four-sided shape, doesn't matter what it is, also adds up to 360, what do we think a five-sided shape is going to add up to?
270.
Why 270? Wouldn't it be more than that? We've got 180, 360,
450.
450.
Or, wait.
540.
Why 540? I do like 540, but why 540?
Is that the right answer, is it?
It's the right answer because
Because I
started just using my brain before adding two zeros.
yeah. So I've got 180, and I go up 180, and then I go up 180 again. Okay. So a five-sided shape, doesn't matter what that shape is, the interior angles add up to 540 degrees. Let's prove this. Anybody recognise this shape?
Pentagon.
It's a regular pentagon. All the sides are the same length, I hope. Okay? So if our rule is right, what did we say the interior angle was for all of them? 540. How many sides have we got? Or how many angles, sorry? 5. So I've got that 540 degrees, and I'm going to split it 5 ways.
I like that.
So 180 degrees.
How did you get
Each
that?
angle should be
I thought he got that in his head then. I'm like, geez, how did you do that?
180 degrees. Can everyone see where I'm going with this? So we've got a rule that said 540 for any five-sided shape. I've given you a regular shape, so all the angles are the same. So we're going to divide it by 5, and we say that each one of those angles should be 180 degrees. Put the crosshairs on the angle, the 0 line on the baseline, read it round, 0, 90, 100, and 8. Should I think about that?
Wait.
That's one though. Do them all.
Ah, good point. That's just one. Oh, angle or shape. Let's talk about other shapes.
Question.
Yeah.
So a six-sided shape will be
Ooh.
720 degrees.
Brilliant.
Well,
Absolutely
actually,
brilliant.
I think we had a
So six-sided, let's part that. Six-sided would be 720 degrees. What do we reckon seven-sided would be?
900.
900. Fine.
So every
You've
time
cottoned
you add
on
a
quicker than
side-
any other class I've had all week for this.
So when you add a
You get
side,
an
you add
eight-sided shape.
180.
So if you start off with 3 sides at 180, 4 sides 360, 5 sides 540.
So each side, each time you add a side, you add 180 to the...
Brilliant. And there's a rule for this. It's an equation. Okay?
What about
Doesn't matter how many. 10-sided, right? Let's do a 10-sided shape.
What about tetradecagon?
No, decagon, right? A 10-sided shape.
Or
10 minus 2 is 8. 8 times 180.
1,800.
1,440.
Brilliant. Okay?
So you can-
1,440 for a 10-sided shape. A 6-sided shape. What do we call a 6-sided shape?
Hexagon.
Hexagon. 7-sided shape.
Oh, good.
Octagon.
7-sided.
I can't remember what
Hexagon.
Octagon.
Pentagon.
That's 5.
Triangle.
I had a septagon yesterday.
Wait, I know this.
Septagon.
Pentagon, hexagon,
Polygon.
What did you say? Hexagon?
pentagon.
No. Right, think
Pentagon,
of
hexagon.
Olympic sports, ladies' sport with multiple events.
Triathlon.
No?
Oh, what's
Remember
it called?
Mary Peters in the 70s getting a gold medal?
I know what you mean, but I can't remember what it's called.
What's the sport that ladies do? The men do the decathlon, the ladies do the...
Oh,
Triathlon.
I can't remember what it's called.
hexagon. What are you doing?
We know what
I'm
you
doing the sports! That was the hurdles! That was the
Shot.
javelin. That's the shot put. Come on.
I know
How many
what you
are there? There were 7
7.
sports. It's the...
Seven are gone.
Heptagon. A heptathlete. You ever heard the expression? A
Do sport,
heptathlete.
we don't even know that.
Blimey, it's like getting blood out of a stone. No, it's not. We'll do shapes next week. We're just touching on them this week. And you're quite correct. A six-sided shape, 6 minus 2 is 4. 4 times 180. I would suggest you do it the other way. A three-sided shape, 180. 4 sides, 360. 5 sides, keep adding 180. Yeah? That's the best way to remember it. This is the formula that does exactly that. And it's absolutely correct. So if I've got 720 degrees, and I've got 6 sides, and it's a regular hexagon, what's each angle worth? What do I have to divide
80. No.
120 degrees. Yeah? So that's how we can calculate the interior angles of any shape. Does that make sense?
Yeah.
You still with me?
Yeah.
So now we've got a way, somebody says, oh, I've got a 10-sided shape. And it doesn't have to be a regular shape. If I said to you, I'm going to draw a 9-sided shape. 1, 2, 3, 4, 5, 6, 7, 8, 9. The interior angles of a 9-sided shape add up to 9 minus 2 is 7, 7 times 180, whatever it is. Yeah? Does that make sense? This is where we now introduce the shapes into what we've done so far. At the start of the lesson, you would have looked at that and you would have your head would have hit the desk. Oh no, that's happening now. Right. You can do these shapes really easily now. It looks complicated, but if we just apply a bit of the rules that we've learned so far and our shape knowledge, we can get these.
Headache.
I don't know.
C
I've had a
Go on then, James. Where could we start? What's a good starting point?
You can do the triangle, which is
Well, no, we can't because we haven't got D and B yet.
G.
Don't jump into it. Do the basics. What could we get first?
So that's 45.
You get B.
So,
Which would
yeah.
be 107.
73. Yeah? So the straight line rule, I've got 107. My straight line rule says G is 73.
Opposite would be.
Can you see that, Lisa? Rather than staring at whatever's down there, can you see what we're doing up here?
Why is that 73?
Because I just told you it's the straight line rule. That's a
Oh,
straight
yeah.
line.
Yeah.
107 plus
Yeah,
73.
like
So if that's 73, what's that angle?
that. 73.
Because
It's opposite.
fantastic. So now we can start looking at triangles. James, I've now got a triangle. What do the angles in a triangle add up to?
180.
So if I know that's 73,
73.
108.
72.
Come on,
Oh.
Adam, you're good at it.
118.
72. D equals 72, isn't it?
I think
So
it's a bit too
72.
much.
62.
Ah,
I know we're close.
use a calculator. It's in front of you.
And then
It's
it's
there.
It
A.
is a straight line again.
Okay,
I see
so we've got
what
62. So what other rule can I use? What about C? What rule could I use for the letter C? I've got this one.
Straight
Oh.
line.
Or you could do it alternate.
Ah,
Do
why is it
alternate would be-
73?
Because it,
Yeah.
alternate,
It's interior.
yeah.
So that's 73. Or it's alternate to this one. It's an alternate angle. Yeah? That one and that one are the same. Brilliant.
45,
So if that's 73 and that's 62, what's A?
45.
Why?
45.
Straight line.
Because it's on a straight line.
And it's also alternate to the...
So that's 45 and that's alternate to...
The... Yeah.
It's not alternate, it's opposite.
Opposite.
So that's 45.
73, isn't it?
So E's 90.
And then E
right
is-
angle. Right angle.
No, on a straight line or a straight line, E must be
135.
135. Good. Some of you got headaches, others actually applied what they've learned today to fill out all those angles. Yeah? So there's a whole host of angles, rules that we can use. The basic rules: lines add up to 180, a circle adds up to 360, opposite angles are the same. Okay? Interior angles add up to 180. You've got alternate angles are the same.
You know, for A and the 45.
A and the 45.
If they ask for like a description, would you say that's corresponding?
Which one, sorry?
Or not? The 45 degrees in the triangle.
Oh, that one and that one. Yeah, it's perfect. Yeah, they correspond. Sorry, they're alternate angles. So that one there is the same as that one there.
Yeah.
They're alternate.
That's right.
Yeah. So you could explain that. Okay. On your worksheet, then, you've got various shapes. Start off with the triangles on the first page that you didn't do earlier, and then turn the page over, and you've got some more complicated shapes.
Wow.
Okay. So that's the third of the 3 objectives done. We're just going to finish the lesson off 10 minutes with something called line of symmetry and rotational symmetry. So a line of symmetry is sometimes known as a mirror line. I did try and get hold of some mirrors so that when we do the practical bits on it, that you could hold mirrors up to the shapes and see what I mean. But if you can imagine, you've got a shape and you can fold it in half and one half maps exactly onto the other half. So this shape here has a line of symmetry that if I folded that shape in half, if it was paper, I can see it, right? So different shapes have different lines of symmetry. The triangle on the left, which is a isosceles triangle, has how many lines of symmetry?
2.
1.
2. 1. It has 1 straight down the middle. Okay? Can't fold it anywhere else because I can't map it. An equilateral triangle, however, has how many lines of symmetry? 3. So if I go from the centre here, through there, through there, through there, I have 3 lines of symmetry. A square, how many lines of symmetry?
2.
2, 4, 6, 8.
8.
Who do we appreciate? 1, 2, 3, 4.
I didn't think it worked itself out like that.
Well, because when you do the diagonals, this corner can fold exactly onto that corner. A pentagon then. They might give you a pentagon and ask you. Sorry, Anthony, that was 5. So from the centre of a corner to the centre of the baseline. From the corner to the baseline, corner to the baseline, corner to the baseline. So they're basic shapes with lines of symmetry. They might mix it up and say, how many lines of symmetry does the letter M have? 1. Straight down the centre. How many lines of symmetry does the letter X have?
2.
2. 1 across the centre, 1 down the middle. They might even get you talking about day-to-day objects or signs. So here we've got road traffic signs, and if I said to you, how many lines of symmetry does the low-flying aircraft sign have?
1.
No.
No,
1.
3.
It's got 1.
3.
It's got 1. Goes from there,
Centre.
if I can just get this
Lane.
pen to go to the right place, through the centre of the aircraft, that way. So it has a line of symmetry. If I said the national speed limit sign, anybody taking their driving test, which one's that? So it's got how many lines of symmetry? 2. We go across that way or straight down the centre. Okay? So they might give you various shapes, and that's lines of symmetry. We're going to cover symmetry in more detail when we do transitions on a grid. We're going to move them around and reflect them on various lines. Let's look at cuboids. That's the one you need to know off this video, okay? Don't worry too much
Symmetry
about the
cuts
others.
a solid shape
It's a
into
cuboid.
2 parts that are mirror images of each other. This plane has plane symmetry. This building has plane symmetry. And this wedge has plane symmetry. This is a plane of symmetry. A solid shape can have many planes of symmetry. This shape has this plane of symmetry, this plane of symmetry, and this plane of symmetry. So this shape has 3 planes of symmetry.
So the cuboid is the one you need to remember.
This
It's got
prism
3 planes of
has
symmetry.
this plane of symmetry
Don't worry too much about the prism.
and this plane of symmetry.
The voice really gets someone else.
So this prism has 2 planes of symmetry.
So with 3-dimensional shapes, we don't talk about a line of symmetry, we talk about a plane of symmetry. So think of a piece of paper cutting through the block. The only one on the syllabus that you need to be aware of is the cuboid, okay? And that has 3 planes, through the centre, down the middle, and sliced across the top.
She was well slow.
That rotational symmetry, we're looking at the shape, we're going to stick a pin in the centre, we're going to spin it round and see how many times it maps onto itself. I don't use PowerPoint very often because I'm not a fan. Okay, so with the first shape, if that was an equilateral triangle, and we're starting at the yellow point, how many times would it map onto itself if I spun it round?
3, wasn't it?
3. Okay, so rotational symmetry has an order, and that order says I go round once, twice, and it maps onto itself 3 times. It has an order of 3. So what about the next shape, the parallelogram? 2, because that yellow point can map onto there, and then back to the start. What about the kite? 1, because it only maps onto itself when it gets back to the start. So any shape has a minimum of an order of 1 for rotational symmetry, okay? So with our kite, it will always map onto itself back at the start, so it has an order of 1. The next shape, anyone remember what it's called?
Hexagon.
Hexagon, 6. Oh god, that's slow. Right, so that's got an order of 6. The next shape, they could give you funny shapes. 4, 1, 2, 3, 4. And finally, the shape at the end,
1.
5. Goes 1, 2, 3, 4, 5. Okay, that has an order of 5.
Oh, God.
No, I'm not going to make you do these. They can do any particular shape. They might give you stars, road signs, and ask you for rotational symmetry. Sometimes they might ask you to compare things that has got an order of rotational symmetry with a number of lines of symmetry. If I said to you shape D, how many lines of symmetry does shape D have?
2.
1.
None.
None. There's no reflection line. I can't draw a line anywhere to get a reflected image. How many orders of rotational symmetry does it have?
1.
Good. So shape D has no lines of symmetry, but 1 order of rotational symmetry. So be aware they don't always match. Okay, that's the learning point from that. You can have a line of symmetry or 2 lines of symmetry or 3, but the order of rotational symmetry might be different. So keep an eye out for that. And that's the same for shape E. It has no lines of symmetry, but it has an order of 2 for rotational symmetry. Because when you rotate it, it maps onto itself once, twice. So just be aware some shapes differ between lines and rotational symmetry. Okay, let's get away from that.
My eyes are going blurry.
Okay, and that's the 4th objective complete. That's the lesson for today. Have you got any questions on what we've covered today?